So hello everyone, welcome to this new video. So in the previous videos we have solved many problems related to the FIR low pass filter design, right? And we have seen the relationship between all of them, and we have found at the end, using the different windows, we have found filter coefficients. Okay, so those videos are available in our channel, so please do watch those videos, guys. If you want to understand it very carefully, please do watch those videos and then come and watch this video. So in this session, right, one problem is there. This one problem is very important and multiple times repeated in multiple question papers. Okay, these kind of problems should be coming. Some indirectly they have given the problem, but I'm going to explain it. It is very easy. Okay, here the problem here is, again, those who have not watched the previous videos, do watch it. Okay, and like this video and then go further and watch this video till the end, because this question is very important. Okay, using rectangular window technique, design a low pass filter with cutoff frequency of 1000 Hz and working at sampling frequency. They have given the sampling frequency also, that is 5 kilohertz, and they have given the length of the filter, that is equal to 7 in this case. Okay, they have given the cutoff frequency, sampling frequency, and the length of the filter 7, but they have not given the value of omega c. So you can see that in the question it's mentioned cutoff frequency, but this is actually FC that they have given. Okay, FC they have given it as 1000 Hz or 1 kilohertz, and sampling frequency FS is given as 5 kilohertz. Okay, now using these two data, you should be finding the value of omega c. They have not given the value of omega c in this question anywhere. Okay, first we should be doing that, then rest of the problem remains the same. So how to find the value of omega c is very simple. First we should be finding the value of FC. Okay, small letter fc. The formula for this is fc divided by fs, that is the cutoff frequency divided by sampling frequency, would be getting you the overall general bandwidth cutoff frequency, that is small letter fc is equal to fc by fs. Okay, this you should be remembering. So what would be getting our fc? 1 kilohertz by fs is 5 kilohertz, right? So kilo would be getting cancelled. 1 by 5 is equal to 0.2 hertz. Okay, but we need this in terms of radians per second, that is omega c. You know that what is the value of omega? It is 2 pi fs, right? So omega c would be equal to 2 pi fc. So it is equal to 2 pi into fc is 0.2. So our final value of omega c is equal to 0.2 into 2 is 0.4 pi. So don't substitute the value of pi because it would be getting complicated further in the problem. So keep this 0.4 pi as it is, radian per second. So this is for this value of omega c. Now we should be solving this problem using rectangular window. Okay, so these kind of problems, indirect problems, should be coming, so please you should be knowing it. So now rest of the procedure remains the same, that is first write the value of hd of omega. In this case it is e power minus j. See here the length of the filter is 7, so I am going to directly write it as 3 omega, because alpha is n minus 1 by 2 and n value is 7 minus 1 by 2, so that is equal to 6 by 2. So 6 by 2 is 3, so that's why I have written directly as e power minus j 3 omega. Okay, that is for, again they have, in this it is low pass filter, they have mentioned it, so the limits are from minus 0.4 pi up to plus 0.4 pi from this omega c which I have got, and for rest of the value it is 0. Now solve for hd of n is equal to 1 by 2 pi, and the limits are from minus 0.4 pi up to plus 0.4 pi e power minus j 3 omega into e power j omega n d omega. So solve this now. 0.4 pi e power j omega is common here, n minus 3 d omega, right? Now integral of this would be e power j omega n minus 3, and the coefficient of omega here is j into n minus 3. The limits are from minus 0.4 pi up to 0.4 pi. Now substitute the limits. E power j 0.4 pi n minus 3 minus the lower limit is e power minus j 0.4 pi n minus 3 divided by j n minus 3. So this would be equal to hd of n is equal to, so here in place of theta what we have, 0.4 pi n minus 3, so sine 0.4 pi n minus 3 divided by 2j goes, so we are left with a pi n minus 3. So this hd of n value is for n not equal to 3, right? So now let us solve for n equal to 3. hd of n is equal to 1 by 2 pi minus 0.4 pi up to plus 0.4 pi e power j omega n minus 3 d omega. Substitute the value of n as 3, so 3 minus 3 is 0, e power 0 is 1, so 1 by 2 pi minus 0.4 pi up to plus 0.4 pi d omega. So the limits, the value of integral of d omega is omega from limits minus 0.4 pi up to 0.4 pi. Substitute the limits, upper limit minus lower limit in place of omega, so 0.4 pi minus of minus 0.4 pi is plus 0.4 pi, so 0.4 plus 0.4 is equal to 0.8 pi divided by 2 pi. So pi gets cancelled, so we are left with 0.8 divided by 2, that is equal to 0.4. Okay, so this is the second value of hd of n. So our final value of hd of n is equal to sine 0.4 pi n minus 3 divided by pi n minus 3 for n not equal to 3, and for n equal to 3 it is 0.4, right? So this is the value of hd of n. Now draw the table for n equal to 7. Write all the 7 values of n up to 0 to 6, that is 0, 1, 2, 3, 4, 5, 6. So here we have hd of n, that is this equation you should be substituting in the calculator. So this here it is omega n, and they have told us to use the rectangular window, so we would be getting all 7 values equal to 1, since we know that the value of rectangular window is equal to 1 for all the values up to 0 to n minus 1, right? Final table is of h of n, that is equal to omega n into hd of n, right? So whatever answer we get here, that only we should be writing it here, since we are multiplying it by 1. And for n equal to 3, the value is 0.4, so here also it would be equal to 0.4. Now substitute this equation in the calculator, that is sine of 0.4 pi, close the bracket, a minus 3 whole divided by pi a minus 3. Press the calc button. For n equal to 0 it is minus 0.0623, here also it is same, and next value for n equal to 1, 0.0935. For 2, 0.3027. Next is for 4, it is a mirror image, so here it is 0.3027, 0.0935 minus 0.0623. 0.0935 minus 0.0623. So these are the values of h of n we have got. If you want, you can check it for 4.3027, for 5.0935, for 6 minus 0.0623. Okay, so these are the values. So this was one kind of problem in this session that I didn't solve till now. So yeah, this was one single problem in this session. So that's all for this session. Like this video and do watch this full video. I hope that you are watching my videos till the end, because the problems are very important, guys. The problems in the subject are very tricky and very important. Okay, if you lose one step also, the whole problem would be getting messed up. So please guys, watch this video till the end, each and every step in detail, and I've tried to explain it to you all. Don't skip any part of the video and watch till the end. These problems are very important. Okay. So that's all for this session guys. Like this video, share this video and channel to a huge number. We'll see you in the next session. Thank you.